So this is a revision lesson about factorizing quadratics and solving quadratic equations. So factorizing quadratics, what we're trying to do is turn an expression on the left hand side here into this one on the right, to put it into brackets. To be able to do that confidently, what you need to be able to do first is go the other way around. So can you take an expression like this one here and expand the brackets? And I would suggest that if you're not so confident in that, then you need to go back and get some practice. Where might you get that? Well, if you go back to this game that we played previously, then that will give you some good practice, and I'll show you where you can pick that up. So there we go. We're trying to turn this expression here and we're putting it into brackets. Why might that be useful? Well, it's useful for solving equations like this one here, and it's useful for being able to draw graphs in that format there. More on that later on. So let's have a look at some examples. First one. Right, so I'm going to try and factorize this quadratic here. First of all, I noticed there's no units term at the end, unlike this one. That's fine. Before we start trying to put it into two brackets, the first thing we should do is check that there's not a common factor there. And in fact, with this one there's a common factor of x, so I can take that outside the brackets and I get x minus 7. It's easy to forget that once we've started trying the examples where there's two brackets, that's an easier type. Now, what about this one here? You might recognize that, or you should recognize that as the difference between two squares. That's a square number, that's a square number. So what's happened there is that the x terms have cancelled out, and there's a reason for that you have the same number here as here, except this is negative. So x plus 4, x minus 4 will work for that. Expand it out and check that that works for yourselves. And there's the classic one, putting it into two brackets. There's no common factor there to take outside, so let's try two brackets. Because it's x squared here, we need to have an x there and an x there. I've got minus 14 here, which means that these two numbers, I remind you, must multiply together to give that minus 14, and those two numbers will add up to give negative 5. So let's start with the multiplying part. So two numbers that multiply together to give minus 14. We're therefore going to think of the factors of 14. So let's just ignore the fact for a minute that it's negative 14. We could have 1 and 14, 2 and 7, and then that's it, isn't it? So I want two numbers that multiply together to give negative 14 and then add together to give negative 5. Well, if you just think about that and play with it for a while, you'll see that that's the possibility, 2 and negative 7. So x subtract 7, x plus 2. When you multiply outside the brackets, will give you x squared minus 5x minus 14. If you were to write x plus 2, x minus 7, then you'd get exactly the same answer, so that is correct as well. Right, some examples for you to try. There are 8 questions. What I'd like you to do is pause the video now, on a piece of paper, try and factorize those for yourselves. Right, how did you get on? Well, if it took you a long time, then maybe you need a little bit more practice, and I could suggest that you come back to this site. This is the URL I was talking about earlier on, teachmathematics.net, and if you come to the activity on factorizing quadratics, there's a nice Excel spreadsheet there that will help you with this. It'll check some of your answers and give you a little bit of help as well. So the answers. Those are the answers you should have got. So pause again and check that you've got those right. Okay, so I'm going to try a few that are a little bit more difficult now. So the one here, we've got 2x squared plus 7x plus 6. There's no common factor of 2 to take outside, so it's a little bit different to the ones we've had before. Right, let's give that one a try. To be able to do that, again, two brackets, no common factor, so it's going to go straight to two brackets, and to get 2x squared I need 2x there and x there. That's the only possibility that will work for me. And then again, I need two numbers that multiply together to give plus 6. So let's think of the factors of 6, 1 and 6, and 2 and 3. There's no other possibilities, and we might be mistaken in thinking that that's the correct answer because 1 and 6 adds together to get 7. Let's just show why that doesn't work. If I were to put plus 1 and plus 6 in here, and try expanding that. That's the 2x squared that I need. Now then, 2x times by 6 gives me the 12x, and then 1 times by x gives me another x, so I've got 2x squared plus 13x plus 6. I've got 13x here and not 7. Okay, so it's not that one. Why does that not work? Well, it's to do with the fact, of course, that we've got 2x squared at the start there. Okay, so hopefully that means that this must be the right combination. Well, let's try it. 2 and 3. If I try entering the numbers in there, if I put 2 here and 3 there, does that work for me? Well, I've got 6x there, and another 2x would make 8x, so that's not right. And let's try a different combination. Let's put them the other way around. So if I work out the number of x's, I've got 4x here and 3x there makes our 7x. And you're running through it, you get the whole thing. So 2x squared plus 7x plus 6. That is correct. Now the key to doing these is just plenty of practice. Right, let's have a look at another one. And this one's a little bit more tricky, and there's a reason for that. In that the number of x squareds that we've got here is 8. Why does it make it more difficult? Well, if you just think about what's going to happen when you put it into brackets, then there's going to be different combinations. You could have at the start there 2x times by 4x. You could have 8x times by x. So you've already doubled up the number of combinations that you need to check there. We've got 9 here, so well, actually we've got minus 9, so the combinations of numbers we've got here are 1 and 9 and 3 and 3, with one of those being negative. So you've got quite a few combinations to try. Now, one thing that you could do is just work through them. Just try them all and see what happens. And in time, with experience, you get to recognize which is correct. So I'm kind of guessing here that I need 3 and 3. Let's try 3 there and 3 there. One of them's got to be negative, of course. So I think, does that work? I'm going to have 6x minus 12. No, I've got that the wrong way around, but I can see that just flipping the signs around there is going to work for me. So if I make that plus and that minus, then that's going to work. So I've got minus 6x plus 12x, and that's going to be the right one. So you can just try different combinations and that works out for you. Now, I'm just going to show you an alternative method for that, because that involves quite a lot of trial and error, and some people don't like that. So there is an alternative way of doing it, and it involves doing the following. So the two key numbers that I'm interested in here are 8 and minus 9. Now if I multiply those two together, I get negative 72. So what I want to do now is try to find two numbers that multiply together to give negative 72, but add together to give plus 6. Oh, can you think of two numbers that for which that will work? That's going to be 12 and minus 6. Now, what we do is we take the 6x and we split it into 12x minus 6x. So it's the same thing, 12x minus 6x is 6x. So I'm going to rewrite this expression here as 8x squared plus 12x minus 6x minus 9. It kind of feels at this stage like we've made ourselves a bit more work. It's a longer expression, but it really helps us with this factorization. So we'll take this part here and this part here separately, and I'll factorize them. So a common factor there of 4x, 2x plus 3 there, and here, well, I've got, let's just think about this for a minute. I've got minus 3 that I could have there, and inside I will have 2x plus 3. Okay, I was just hesitating over the negative whether to take that one out, and you notice that those two factorized parts are exactly the same, so they're common to both expressions, and so I can factorize that. I can take that outside and leave myself with the 4x minus 3, which I've got there and there. Exactly the same answer. So some people prefer that method. So you've got to choose which is the best method for you, and you might adapt it depending on the type of quadratic expression you have to solve. Right, some practice for you now. Here are 7 questions. What I'd like you to do is pause the video and have a go at those on a piece of paper for yourself. Right, back again, so you should have done those. Here are the answers to those questions. So again, pause the video and check that you've got those right. Notice there's a couple of interesting ones at the bottom here where I've done a couple of things. I've taken a common factor outside here of x before I did that factorising, and in fact when I took the x outside there was still the difference of 2 squares here, so that bit was possible to factorise too. The same with this one, there was a common factor of 2x which I took outside, and again it was a difference of 2 squares. It looks a little bit unusual there, but that does factorise there. So hopefully that's given you a bit more practice, that's reminded you about factorising quadratic expressions. Now we're going to move on to equations. So what I want to be able to do is solve equations like this and like this. Right, before I start, just consider the equation that I've got right here. So what I've got here is 2 numbers that when I multiply them together I get 0. So what does that mean about those 2 numbers? Well, that means that either A must be equal to 0, or B must be equal to 0, or both of them must be equal to 0. And that's the key thing that we need to be able to use when we're solving quadratic expressions. Because what I've got here is exactly the same idea. I've got 2 numbers that when I multiply them together I get 0. So this number here, x plus 2, must be equal to 0, or x minus 3 must be equal to 0. Well, if x plus 2 is 0, then x is minus 2. If x minus 3 is equal to 0, then x is equal to 3. That's how we might solve that equation. And we see there, if you just put those values back into the equation, then that will make that work. It'll make it equal to 0. So if I start with x plus 2, x minus 3 should be equal to 0. So let's try minus 2 to start with. Minus 2 plus 2 there, and minus 2 minus 3 there is equal to 0. So here, that's the whole point. I get 0 there. I'm going to multiply that by minus 5. That's equal to 0. Now if you did that with the other one, you'd get a similar idea. So let's try that up here. X plus 2, x minus 3 equals 0. So this time I'm going to put 3 in. So 3 plus 2 times by 3 minus 3. You can probably see why this is working there now. So that's 5 times by 0, which of course gives you 0. And those are the only 2 possibilities that will work for that equation. Now then, what we're aiming to do is solve equations in this form here. So this is a quadratic equation. So what we're trying to do is get it into the form that we just had here. So it's in the factorized form. And when we've got it in that form, we can use this method to find the solution. So let's try and factorize it. I'll notice first of all, I'm going to look for any common factors. I can see that there's a common factor of 2, so I can take that outside. So let's rewrite that. And let's try and factorize what I've got inside here. So that's going to work for me now. So that means that 2 times by this is equal to 0, which actually means that that part must be equal to 0. We could divide through by 2 and simplify that for ourselves a little bit. So that means that x minus 5 is equal to 0, or x plus 2 is equal to 0, or both. So x is equal to 5 and x is equal to minus 2. And again, if you substitute either of those values into this expression or this equation here, then you should get 0, and I invite you to check that. Okay, so hopefully that worked for you and you got an answer equal to 0. Right, let's have a look at another one. So believe it or not, this is a quadratic equation that we can solve, but what we want to do is have all of the equation to be equal to 0, which involves a little bit of rearranging. I'm going to have to get rid of what we've got on the right hand side, which involves subtracting 2 from both sides of the equation and subtracting 3x from both sides of the equation. So that's going to leave me with minus 5x subtract 3x, which is minus 8x, and then 18 subtract 2, which is 16. So what we've got there is a quadratic equation where we've got 0 on one side, and we can use the previous method. So what do? Let's put it into two brackets, and very easily we can see that that's our solution. So in fact we've got what we call a repeated root here. We've got the same thing twice, and you could, if you wanted to, write it like that. What does that mean? That means that x minus 4 equals 0, so x is equal to 4 is the only root of that equation. Okay, so that's basically it for the theory. It's time to get some practice, and the more you can practice these, the better you'll get, quicker and quicker, and you should be able to do them fairly easily. So here's some questions for you to try. I suggest that you have a go perhaps at just the odd questions here. I might print these out for you and put them on a sheet, and I'll give you the answers to those as well. And there's some more here, and again perhaps just the odd questions will be plenty of practice. Okay, so you can pause the video and have a go at those two. Right, so if you're back again, that means that you've had a go at those and you want to check them. Probably a little bit easier if you've got this on paper, so you can check as you're going along, and in fact I will print that out for you and make sure you have it, but just in case you don't, those are the answers. Right, so that's it for solving quadratic equations. The next time we will have a look at the quadratic formula and the method of completing the square.